Okay, finishing example 1. Remember, we subtracted 20 from each side. So 20 minus 20 is 0, so that cancels out. We bring down the 6y. 2 minus 20 is a negative 18. So after that, we got 6 times y is equal to a negative 18. So now we're going to divide both sides by 6. And even though they're not showing you that step, you should know this by now with no problem. So we're going to divide both sides by 6. So now 6 divided by 6 is 1. So that's 1y. Once again, the 1 does not have to be written because all we see is 1y. And then a negative 18 divided by a positive 6 is a negative 3. So our final answers then are x is 4 and y is a negative 3. Okay, now in example 2, we're going to solve a system by multiplying and subtracting. Solve a system by multiplying and subtracting.
So, when we're looking at systems of equations, that means we have more than one equation, than one unknown. What we want to do is to try to see if we can kind of divide and conquer. Let's take a look at an example where it turns out multiplying and subtraction, they're going to be the keys to unlock an answer. Let's check it out. So I want us to solve this system of equations, 6x plus 2y equals 14, and 3x minus 5y equals negative 17. All right, so what am I going to do here? Well, I look at this and say, boy, I wish there were only one variable. Whee! That would be good, because then I know how to solve one equation with one unknown. So the question is there any way for me to kind of massage these to get it just down to one variable? Well, I look at this, and here's what I see. I can do something to one side and the same thing to the other side. It's not going to change an equality. Well, I see 6x, blah, 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 and I see 3x, blah, 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 blah. So check it out. If I were to multiply this second equation by 2 all the way through on this side and this side, it would still be an equality. But check it out. When I then multiply by 2, this would become a 6x. Now let's just visualize that and not worry about the details. This would be a 6x, this would be something times 2, this would be something times 2, whatever. 6x and 6x, there's a coincidence. Which means if I took this equation and subtracted this equation, the 6x's would drop out, and I'd have an equation, one equation, just in terms of y's. That's what I mean by divide and conquer. See if you can put the equations together in some way to get one of the unknowns to just literally fall out or add to give 0. So let's see if we can make this strategy real. So the first thing I'm going to do is multiply the second equation through by 2. So let's take a look at 2 times the second equation. So there's some work involved here, I admit. So the left-hand side is going to be 2 times this and 2 times that. We have to make sure that each and every piece gets multiplied by 2. So that's going to be 6x, and then 2 times negative 5 is negative 10y. And then on the right-hand side, we have to multiply that by 2. And so 2 times negative 17 is negative 34. So this is the same equivalent. It's an equivalent equation to this one. All I did was just take this and multiply both sides by 2. Now, this is interesting, because what I can do is just rewrite this one and then actually subtract the 2. So let me actually just grab this for a second. So I'm going to grab this, and I'm going to pull it down a little bit. And now what I'm going to do is write this original one. 6x plus 2y equals 14. And since both of these are equalities, if I take this and subtract this, that will be equal to this subtracted with this. And so I'm going to subtract. And what that means is that I'm going to subtract every single thing, which means each of these signs are going to change. So when I subtract this whole thing, here's what it means. I'm going to show you kind of a little enlarged to show detail. Nothing's going to happen here. Everyone calm down. But on this side, I have to subtract every single term. So I have to subtract this. That's negative 6x. I have to subtract negative 10y. That becomes a positive 10y. And on this side, I have to subtract here. If I take a negative of negative 34, that becomes 34, and now I can just think about adding. And if I add, that's easy. So if I add, what's 6x plus negative 6x? That is 0, and that was the entire intent. If we got something with x's, we're not making any progress. But now that's gone. Now I have 2y plus 10y. Well, that gives me a total of 12 y's. And on this side, 14 plus 34 is 48. Well, this is awesome.
All right, so now all he is doing here is what we learned in the past. He's taking the negative and distributing the negative. And all you got to remember is negative means opposite. So what's the opposite of a positive 6x? A negative 6x. What's the opposite of a negative 10? A positive 10. What's the opposite of a negative 34? A positive 34. And then we're going to add going down.
So, you see what we just did? We now have one equation with only one unknown. We know how to solve for this. It's really easy. All you have to do is divide both sides by the 12. And I see that y has to equal 4. And there we are. We know what y has to equal. So all that work was just to get what y equals. But we're not done yet, I'm sorry to say, because we have to figure out what x equals. But that's actually not that hard, because all we have to do, since we know that y is 4, we can just dispose of the y and replace it by what we know it equals. It equals 4. So that unknown is now known. And we can substitute that 4 in for y in this equation or this equation. It doesn't make a difference. Either one will lead to the same x value. So let's just do it on the first one just for fun. So now I'm going to take the answer we found and plug it in for y to figure out what the corresponding x will be. So if I take a look at this, I see that 6x plus 2 times y. That's 2 times 4. 2 times 4 is 8. So I'm just going to write 8 in here, and that equals 14. And then solving this is not a big deal. We just are going to try to undo the adding of 8 by subtracting 8 on both sides. And I see 6x equals 14 minus 8 is 6. I'll undo the multiplication by 6 by dividing both sides by 6. And this shows me that, in fact, x equals 1. And that is our value for x. So our solution, in fact, is an ordered pair, x comma y, which in this case would be 1 comma 4. That's what we just found, 1 comma 4. And we can actually check our answer. So if you want to see if our answer is correct, we could check it by letting x equal 1 and y equal 4 and see if, in fact, the answer checks. Let's see if we can do it actually in our head. Let's do a little bit of mental math and see. So I'm going to put a 1 in for x and a 4 in for y. So let's be careful. 6 times 1 is 6. 2 times 4 is 8. And 6 plus 8 is 14. That checks. Okay. Now, let's see if the second equation also holds. We have to check both equations because we want a solution to the system. So, x is still going to be 1 and y is still going to be 4. Here we go. 3 times 1 is 3. 5 times 4 is 20. So what is 3 minus 20? 3 minus 20 is negative 17. Checks! And so we see, in fact, that this answer of 1 comma 4, which means x equals 1, y equals 4, actually satisfies both equations, which means we actually have found the solution to this system of equations. Looking at systems of equations are just great fun. First of all, they're extremely useful in all sorts of fields, including economics and science and math and everywhere. So it's important to be able to do it, and it's even more important to realize that using this divide and conquer method, where we try to multiply and then subtract so as to get rid of one of the unknowns, leaves us with just one equation, one unknown. We solve that with confidence, and with that new answer in hand, we can go back, replace that unknown because it's known, and now we just have one equation and one unknown, and we can find the other unknown. You can check your answer to make sure that we didn't make any little arithmetic mistake along the way, and then you are good to go. Have fun trying to uncover the unknowns in your life. I'll see you soon.